Now screen is shared.
Yes, sir.
Okay, so I am saying what, suppose there is an object of mass m 200 gram, right?
Okay, sir.
A mass m of 200 gram is thrown vertically, right,
Yes.
vertically upward with an initial velocity of suppose 40 meter per second, right? Find the maximum height it gains. So have you got the question what I am asking you? The question is asked that there is a mass m of 200 gram and it is thrown vertically upward like this. So when you throw any object vertically upward, so after reaching the maximum height, it will be at rest for short a while at the maximum. It will come to rest here for a very short period of time, and then it will again come back, right, due to gravity. So the maximum height which it gains, you are required to find out. Okay, you are asked to
Okay, sir.
find that the mass of 200 gram is thrown vertically upward with an initial velocity, and the initial velocity of the object is 40 meter per second. So how high it gains? Okay, so can you find it? Can you find out?
Okay, sir.
And remember one thing that
Yes, sir.
I have told you yesterday. If we are moving up vertically upward, right? If any object is in motion with vertically upward, so g will be taken as negative. Whereas if object is moving vertically downward, then g will be taken as positive. Because when the object is going upward, then there is a retardation,
Negative.
negative acceleration. When object is moving downward, then positive acceleration means velocity is increasing, and in case of upward motion, velocity will decrease. Okay, fine.
Okay.
Okay, try to solve this question.
Yes, sir.
Okay, try to find out.
Okay, sir.
I think let me tell you this question how to do. Okay, have you find something?
Sir, so we use the second formula.
Okay, and I am adding one more thing in this question. The first thing is that you have to find out the maximum height it gains, and add one more thing, and also find and also find and also find the time taken to reach maximum height. Okay, you are also
Okay, sir.
required to find out the time taken to reach the maximum height, that how long it will take to reach at the maximum point. Okay, now see here, to solve
Yes, sir.
this we know that it is thrown with vertically upward with an initial velocity, and initial velocity is u, which is 40 meter per second, right? And the
Yes, sir.
gravitational acceleration g, the value of the, now see one thing, the value of gravitational acceleration is 9.8 meter per second square, but for the sake of convenience of the calculation we can take it approximately equal to 10, right? So taking the g is equal to
Yes, sir.
10 meter per second square. And also one more thing, since it is a vertical motion, so g will be taken with the negative sign, right?
Yes, sir.
G will be taken with negative sign, so this is minus 10 times of meter per second square. And since it is given when you throw an object vertically upward, then after reaching the maximum height its final velocity will become 0 here, right?
Yes, sir.
The final velocity of the object will become 0, that is the final velocity is 0, and we have to find out it maximum height. So we can make use of the third equation of motion, which is v square is equal to v square plus 2gh, right? And here v is what, 0, and u is the initial velocity, which is 40 square, and 2gh, this is 2 into g is the gravitational acceleration, which is in fact minus 10, right?
Yes, sir.
This is minus 10, and the height which is to be found. Now this term is of negative sign, so if you bring this term toward this side, so the sign will become positive, right?
Yes.
Okay, so after solving you will get here 10 into 2 or 20, so this is 20h, and this is 14 square, which is 1600. Okay, so the maximum height is going to be 1600 upon 20, and this 0 is cancelled out, this is 2, it is 16, and 1 0, so the maximum height it will gain, which is 80 meter, right? Have you got the same answer or something else? Hello? Hello? Are you listening to me? Hello? Can you hear?
Yes,
Can you hear me?
right.
Can you hear me?
Yes.
Okay, so have you got the same answer? 80 meter? 80 meters?
Yes, sir.
80 meter same answer. Okay.
Yes, sir.
Okay, and also find the time taken to reach the
Yes,
maximum.
sir.
Find the time taken. Can you find the time also?
sir.
Try to find out the time.
Yes, I'll try.
Okay, fine.
Okay, sir.
Have you calculated the time? In order to calculate the time, I think you can use the first equation, which is v is equal to u plus
So I'm
g.
calculating.
Yeah. When you use this first equation of motion,
80
v is 0 and u is what?
GT.
U is 40,
Yes, sir.
and this
U
is
is
40, and this is plus, g is minus 10 into t. So when you bring this term toward the left side, you will get 10t is equal to 40, right? And the t will become equal 40 upon 10, fine. 10 into 4, 40. So you will get 4 seconds. It means it will take the 4 seconds to reach the maximum height, fine. Okay. So this is how you will get the time. Okay, what happened? Have you disconnected? Is there was network issue, I think, from your side? Hello? I think today there is network issue from your side. Okay? Hello, can you hear me? Can you hear me? Hello? Can you hear me? Can you hear me? Reply something. Speak something. I'm not listening to you. Hello? Are you listening to me? Have you gone somewhere? Hello? Hello? Hello?
Hello, sir. Can you hear me?
Yeah, now I can hear you.
Hello.
Have you gone somewhere? I was not able to listen you. Now everything is okay?
No, I was here only, but my screen was, yes, sir, my screen was black and I couldn't find my mic, so that's why I couldn't speak.
Okay, okay. Now it is okay.
Hello, sir, I can't hear you.
I am speaking. Hello? Are you listening to me?
Yes, sir, now it's okay.
Now it is okay? Now it's okay?
Yeah.
Okay, okay. Now this is how
Yes,
to
sir.
find out the time. Okay,
Yes, sir, now it's okay.
time is 4 seconds, right? Time is
Yes,
4 seconds. We have calculated. Note it down. First of all, note it down.
sir.
Note it.
The answer, 4 seconds.
Okay, answer is 4 seconds. Okay. Now shall I delete this? Have you noted this? Hello?
Yes, sir.
Have you noted this?
I got the answer.
Okay, so shall I delete this and begin with the new topic?
Hello, sir, can you hear me?
Yeah, I can hear you.
Yes.
Okay, so
Yes, sir.
I'm going to delete this. Okay.
Okay, so you can delete that.
Okay, okay, fine. Now,
Okay, sir.
okay, the next thing that I'm going to take, that is the linear momentum. We have already told you about the linear momentum. Okay. Linear momentum is what? It is defined as the product of mass and velocity. It is represented by P, and it is the product of mass and velocity, right? Okay. What is the unit of the angular linear momentum? Can you tell me what is the unit of the linear momentum? Hello? 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 Are you listening to me? Are you listening to me?
Yes, sir.
No network problem. There is no network problem from my end. My end is everything is okay. I think network problem is from your side. Everything is okay from my side. Hello? Can you hear me? Okay, so angular momentum, tell me the unit of the angular momentum. Tell me the unit of the linear momentum. Unit of mass is kg, and the
Movement of angular momentum.
unit of the linear momentum. I am asking you unit of the linear momentum. So mass, unit of mass is kg, and the velocity is meter per second, right? So unit of the linear momentum will be kg meter per second. Okay.
Unit of linear momentum.
Yeah.
Unit of linear momentum.
Yes. This will be kg into meter per second. Okay.
Okay,
Okay, unit of the linear
sir.
momentum is kg meter per second. Now the next thing I am going to explain you, that is the conservation of linear momentum. So put the heading of the conservation of linear momentum. Okay, this is important topic, conservation of linear momentum. Okay.
Okay, sir.
Okay, put the heading of the conservation of linear momentum. Okay, shall I continue?
Yes, sir.
Okay, in the conservation of linear momentum, actually what is in this, if you have the two objects, suppose, okay, if there are two objects, suppose one object is this and the next object is this one. Suppose this object has the mass m1 and this object is with mass m2. Okay. Okay.
Okay, sir.
And suppose these two objects are moving with the same in the same direction with a different velocity. Suppose the initial velocity of this object is u1 and the initial velocity of this object is u2. Okay, now if we are considering the case that u1 is greater than u2, that is the first object is moving with higher velocity than the second object. So after some time this object will collide with the second or not? Tell me. The first object will collide with the second object. Okay, suppose
Yes,
this
sir.
object collides, and that is there is a collision between the two objects, and when there is a collision between the two objects, then their velocity will change. That is, the velocity of this first object becomes u, final velocity of the first object is v1 and of the second object is v2, right?
Yes, sir.
Okay, so final velocity of the first object will become v1 and the second object will become v2. Now what happens, using the collision, the total linear momentum of the object will remain conserved. This is the conservation of linear momentum. That is, the linear momentum of this first object and the linear momentum of the second object will remain same. That is, the linear momentum of the total linear momentum of this object will be equal to the sum of the linear momentums of these two separate objects. Okay.
Okay, sir.
And how can we get it? Now see here, when this first object will collide with the second object, so the first object will apply the sum force on the second object. Okay, this is object
Okay.
1 and this is object 2, this is 1 and this is 2. So when the first object will apply the sum force on the second object, then as per the Newton's third law of motion, the second object will apply some force on the one object also, due, due to the third law of motion. What is the third law of motion? Tell me. Can you repeat?
What, sir?
Can you repeat the third law of motion which we have discussed yesterday?
Yes, the third law of motion is
To
to
every
every action
action
there
there
is
is, okay, equal and
is
opposite reaction.
equal and opposite.
Okay, so I am telling
Yes,
you
sir.
that when this first object, that is one object, will collide with the second object, so first object will exert a force on the second object. Now we will find this force, and how we will find? Now let's see this. Suppose if I write F12, so the symbol that I have used at F12 means the force on object 1 due to object 2, right? This means force on body 1 due to body 2. And if I write F21, this means force on object 2. This is the simple way to represent. It may be different in the different books, and I am taking here 1 2 means force on object 1 due to object 2, right?
Yes, sir.
Force on body 2 due to body 1. Okay, now
Okay, sir.
now tell me, how can we find F12? F12 is actually what? F12 is the force on body 1. So we will take the force is we know that the force is what? Mass into acceleration, right?
Yes, sir.
Okay, if force is the mass into acceleration, so it means F12 will be equal to m1. M1, that is mass of object 1, and it is due to object 2. So we will take the acceleration of the second object m12, and that will be equal to second object v2 minus this is m1 f12. This force f12, one force will be f12 and the second force will be of minus equal to f21, because f12 force is applied on object 1 due to object 2, like f12 is like this, and f21 force is on the second object due to first object. Okay,
Yes, sir.
when you solve this, so the expression that you will get, I'm directly going to write down and having the some examples on that, rather than proving this. We can also prove this, but that will take time, and first of all we will take this some questions on that. When you solve this, you will get m1 u1 plus m2 u2. Okay,
Okay, sir.
m1 u1 plus m2 u2, that will equal to m1 v1 plus m2 v2. Okay, this is
Okay,
m1
sir.
u1. M1 u1 is what? This is the total linear momentum before collision, right?
Yes, sir.
This is total linear momentum before collision. Total linear momentum before collision, and m2 v2 is what? Total linear momentum after collision, and this will equal to, this is total linear momentum after collision. Okay,
Okay, sir.
so this is the law of conservation of momentum, which states that during the collision between the two objects, the total linear momentum of first object will equal to the total linear momentum of the second object. Okay,
Okay, sir.
okay, fine. And when you find out the
Yes, sir.
f12 and f21, let me show you on your textbook also. This is your textbook. We will put the some questions. First see this. Okay, that thing we were taking, like the first object, force on the first object and the force on the second object. So the similar case we will also take here. If we are taking f12, that is the mass of the first object. If we will take the f21, that is the mass of the second object. Okay,
Okay. Okay, sir.
okay,
Okay, sir.
okay. Let me explain you little bit more. Now see here, if we will find f12, okay, f12 is actually what? This is m1 and the acceleration of the first object. So final velocity is v1 and initial velocity of u1, and this will be divided by 2. In the similar way, if we are taking f21 will be what? m2, that is the mass of the second object, and final velocity of the second object and initial velocity of the second object, and this will be divided by 2. Okay,
Okay, sir.
okay. Now when you use this third law of motion, which is to every action there is equal and opposite reaction. So by third law of motion, by third law of motion, f12 will be equal to minus of f21, right? That is, these two forces will be equal but opposite in direction. Negative sign shows that to every action there is equal and opposite reaction, right?
Yes, sir.
Third law states that equal and opposite reaction, that is direction will be opposite to both. So if we will take these two terms equal and put in this expression, so what you are going to get here, now see here, this is m1 of, now when you open the brackets simultaneously, so this is m1 v1, right? m1 v1 and minus m1 u1. We are simply opening the bracket, and this is t, and this is negative term. Is everything visible on the screen, whatever I am writing?
Yes, sir.
Okay. When you open this bracket, this is m2 v2, negative sign is outside, and this is m2 of u2, right? When you divide it
Yes,
by
sir.
t. Now see here, now these two terms t and t will cancel out, right? So what
Yes.
thing you are going to get here? Open the bracket, this is m1 v1, and this is m1 u1, and when you open the bracket, this is minus time of m2 v2, and minus plus, right? So this is
Mm.
m2 and u2. Now what thing we are going to do here? Actually, this is m1 v1, okay?
Yes.
So keep it here, and this m2 v2 term, bring this toward this side, okay? Bring term toward this side, and this term toward that side. So m1 u1 will become positive here, right? This will become m2 v2,
Yes.
and when m1 u1 will come to this side, so this will become m1 u1,
Yes.
and this will become m2 u2, okay?
Okay, sir.
So now what thing you have got from here? This is m1 u1 plus m2 u2, and this is m1 v1 plus this is m2 v2. Now this is the same thing that I have written here, right? That is the total linear momentum before collision will be equal to the total linear momentum after collision. Fine.
Fine, sir.
Have you got the thing?
Yes, sir.
Is there any doubt at any step?
No, sir.
Okay, so have you noted it, or you have to note it?
I have to note it, sir.
Okay. Okay, then start noting down. Is it okay, or do I need to scroll in the some direction?
No, no, sir. It's fine.
Okay, start.
Sir, I have to draw the diagram and all.
Yeah, yeah. All the diagrams need to be okay.
Okay, sir. Okay, sir.
Okay, write this quickly, and then we will take question.
Okay, sir. Sir, what is after total linear momentum before collision equals to total linear momentum after collision,
yeah,
right?
yeah, total linear momentum after collision, right?
Okay, sir.
Okay, have you noted this red portion as well or not?
Sir, red one I'm doing now.
Okay, do this, because actually this is the way to reach this final result of this linear momentum, right? You cannot skip this.
Yes.
Note this down.
Yes.
Shortly I will also provide you some questions for the practice session. Okay,
Okay, sir.
okay, have you done this?
So 1 minute. Yes, sir, I'm done.
Okay, now fine. Now consider the one case which is important of this linear collision, conservation of the linear momentum. Okay, now consider here, when a gun and bullet, right? When a bullet is fired from gun. Now take this example and understand this. Okay,
Okay, sir.
suppose this is gun and there is a bullet, right?
Okay, sir.
Bullet. Suppose the mass of gun. Suppose the mass
Can you
of the gun is represented by mg. G stands for gun for this representation, and the mass of the bullet I have taken it with b, right? M subscript with b. So when the gun is fired, so what happens, actually the spring collides with the bullet, right?
Yes, sir.
Spring collides with the bullets and there is a fire and the bullet comes out. Before collision,
Yes.
right, before firing the gun and the bullet both was at rest, right?
Yes, sir.
Gun and bullet both was at rest, and after collision the bullet will start moving in the forward direction with the final velocity, and the gun will move backward with the jerk, and this jerk will experience to the gun holder, whoever is holding the gun. The backward velocity which is experienced by the gun holder is called the recoil velocity. Is called recoil velocity of the gun. Okay. So if we apply the conservation of linear momentum here, that is the total linear momentum before and total linear momentum. Lm I have taken the short form for the representation of the linear momentum. Okay.
Okay, sir.
After collision, so we know that total linear momentum before collision is m1 u1 and the m2 u2, and after that is m1 v1 plus m2 v2, right? So when you see
Yes, sir.
here the initial velocity, that is the before collision, when the gun is not fired, both thing was at rest, gun and bullet both was at rest, that is u1 is also 0 and u2 is also 0, right?
Yes, sir.
So because of these two terms 0, this whole term becomes 0. Is there any problem?
No, sir.
That means this expression, which is m1 v1 plus m2 v2, m1 v1 plus m2 v2, this will become equal, right? Equal to 0.
Yes, sir.
Now suppose m1 is mg and v1 is the vg. Vg stands for the velocity, final velocity of the gun, and m2 suppose I have taken for mb, that is bullet, and this is the velocity of the bullet, and this will equal to 0. So if we want to find out the velocity of gun here, so this is mg into vg equal to minus velocity mass of bullet and the velocity of bullet, right? So the velocity of gun
Yes.
from here will be equal to minus mb into vb. Vb stand for the velocity of bullet, mb stand for the mass of the bullet, and mg, that is the mass of the gun, right? So this velocity is called the recoil velocity, right?
Yes.
This velocity is called the recoil velocity. Okay, since the mass of the gun, now see here one thing, if I represent mass of gun by mg and the mass of the bullet by mb, now tell me which quantity will be greater. Obviously mass of the gun will be greater than the mass of bullet,
Yes.
and,
Yes, sir.
and hence the velocity of the bullet will be greater than the velocity of the gun, right?
Yes, sir.
That is, bullet will move faster than the gun. Is there any doubt?
Yes. No, sir.
Okay, don't need to write this, I had told you just for the understanding purpose, and now I am going to give you another question. Okay,
Okay, sir.
let's take one question from your textbook. Okay, suppose this question, okay, can you see the question?
Yes, sir.
Can note this down. Note this question. Okay,
Okay, sir.
now let's see how to solve this question. Okay, suppose the mass of it is given that the bullet of mass 20 gram is horizontally fired with the velocity of 150 meter per second from a pistol of mass 2 kg, right?
Yes, sir.
Mass of pistol, suppose mass of pistol I have taken this with m1 and which is 2 kg, Now make sure that all the units are in standard system, which is MKS. Okay, so never forget
Okay,
to
sir.
convert these units in the MKS system. Mass of pistol, this is 2 kg, and we will take the mass of bullet as M2. Mass of bullet as M2, which is given as 20 gram, right? So we need to convert it
Yes.
into kilogram. How will do? We will divide it by 1000, right?
Awesome.
So
Yes,
this
sir.
0 will cancel out, and this is going to be 2 by 100, which is 1 by 50
0.0.
kg. Okay,
Okay.
is it okay?
Yes, sir.
Okay, now the mass of the we have to find out the required velocity of the pistol, that is backward velocity, and required velocity we are taking it with v1, required velocity of gun. Required velocity of gun is v1, and suppose we have taken this is to be found out. And the second thing is velocity of bullet. Velocity of bullet, that is v2, which is given as 150 meter per second, right? So
Yes, sir.
recently we have seen that in case of the bullet, when it is fired from gun, we have the total linear momentum, which is m1 v1 plus m2 v2. This is obviously equal to 0. Why? Because the before collision all the things are at rest, right? The bullet and the gun both are at rest, so total linear momentum before collision will be 0, right?
Yes, sir.
Okay, so we have used that statement directly. So m1, which is the mass, and we have to find out the v1 here, which is the required velocity. So similarly m1 v1 will be equal to minus time of m2 and v2, and minus m2 is what? M2 is 1 by 50 here. This is 1 by 50, and v2 is the velocity of the gun, which is 150, right?
One.
And
Yes, sir.
and this is v1, and m1 will come in the division here, and m1 is the mass of gun, which is 2 kg, right?
Yes, sir.
Mass of gun, which is 2 kg. Now you can see here how when you solve this 0 will cancel out, and 5 is a 15, right? So this is
Yes, sir.
minus 3 upon, and this is 2. Minus 3 upon 2, this will be minus 1.5, and the velocity is in meter per second, right?
Yes.
Now see here, negative sign indicates what? Negative sign indicates that this velocity is in backward direction. Okay,
Okay, sir.
here negative sign indicates that this is the backward jerk actually, and this will be experienced by the gun holder. This is backward jerk. Okay,
Okay, sir.
now you got how to solve such questions.
Yes, sir.
Okay, have you noted down, or you have to note it?
I have to, sir.
Okay, note this question, and your homework is that you will go through such questions of the linear momentum, and if you find the difficulty, so we will discuss it tomorrow, and then we will take any chapter of the chemistry. Let me know that what particular topic of the chapter you are required to begin with, or we can take any chapter of the chemistry from beginning.
So we can take any chapter, like the first four are coming. First four.
Okay, first force, in which atoms and molecules are also included.
Atoms and molecules are also included. Yes, sir.
Okay, so actually, as per my opinion, we should begin with the atoms and molecule, because this is the very basic chapters. This will give you the basic idea, like atomic number, number of proton, cations, anions, and how the chemical formulae are formed. Okay,
Okay, sir.
so this will we will begin with this topic, and the next chapters, some
Okay, sir.
chapters like the matter surround us pure. These chapters are
Yes, sir.
theoretical purpose, but the atoms and molecules are the most important chapter.
Okay, sir.
Okay, so note it down.
Okay, sir. Sir, recoil velocity of gun when V1 equals to
Question mark. That is to be calculated.
what, sir?
Question mark. Question mark.
Okay, sir.
Question mark. Because that is to be calculated, right?
Yes.
That is question mark. So this is the way to solve any question. You have to write all the steps sequentially and in systematic way, right?
Yes. Yes, sir. Done.
So uh, now your homework is you will try these some questions from your textbook like I'm showing you, and if you find any difficulty, so first of all tomorrow you discuss with those difficulties, then we will move to the next chapter, right? You will take the examples from your
Yes.
textbook, okay? Like such examples you are looking at this screen,
Yes, sir.
right? Okay.
Yes.
Okay, since we have the limited time, so we will not pay whole like 1 week on the just one chapter. Actually, we will take the topics, important topics, and we will get through all the important concepts and the questions. In this way, we will have to move.
Okay, sir.
Okay, is it okay?
Okay, sir.
Fine. So, okay, keep it revised and try some questions from your side. Okay.
Okay, sir.
Okay. Should I disconnect this now?
Yes, sir. Okay, sir.
Okay, fine.
Okay, bye, sir. Thank you, sir.